we have seen the modulation techniques in analog domain. That means when the signal was analog, then how to do the modulation. Now, a similar counterpart are there also available when the signal is a digital signal. That means if there is a binary input, then in that case, how is the modulation going to happen? Okay, so this is what we are going to cover in this lecture. So, so let the career be, yeah. So let us have a sequence. Let us have a sequence, any sequence. Okay, let this be like this. Let this be the sequence, and this is the binary input sequence. Okay, let this be the binary input sequence, and we, if I have to plot this in terms of waveforms, okay, if I have to plot this in terms of waveforms, what should I say? Uh, let this be, let us say that 1 is represented by a positive pulse and 0 is represented by a no pulse. So 1 is represented by a positive pulse and 0 by a no pulse. If that is the case, so let us first partition this into, partition the x-axis into time interval, and let us say that this is dB, this is dB. Okay, so and this is time. So if I have to draw this, 1, I'm saying we are going to represent this thing by a positive pulse, and then 0 remains 2 zeros, and then we have 2 ones, then a 2 0, and then another one, and then you're going to go ahead. Yeah, so this levels AK, let these be AK is equals to 1 and AK is equals to 0, and let this is the our message signal MT. Okay, this is the message signal, or the modulating signal. So, and if I have the carrier wave, let us say that we have a simple cosine wave as the carrier. Okay, we are going to draw this. And let us say in this TV, the carrier wave has some integer multiple of the number of cycle, and let us assume that these cycles to be, let us say that these have 2 cycles. Okay, let us say that this has got 2 cycles like this. Okay, this is the, so it goes like this, the carrier. Okay, and this is what we are saying, this is cos omega ct, and this is the carrier wave signal. So then what should be the modulated signal in here? For this case, when the message signal is empty, and we are talking about if we are talking about amplitude modulation or amplitude shift keying, so what should be the modulated output if you are talking about the amplitude shift keying? So we want to obtain this ASK signal, which is, that means the carrier is modulated by the amplitude of the message signal. Okay, so the carrier, the amplitude of the carrier changes by the message signal ASK, which is amplitude shift. We have already seen this. We have already seen this thing in the context of when the signal is digital and it is analog instead of digital. So that we call this thing as, was there a special name given to it? Or am I audible to everyone?
Yes, sir.
Okay, okay. Yeah, I cannot see. Okay, now I can see. Okay, yes. So what should be the amplitude shift keying signal? We have seen this thing. We have seen the amplitude modulation. Okay, in the amplitude modulation, if the signal is a binary input sequence, if it's a message signal which is digital, then that is called as amplitude shift keying. Okay, or this is also called as, because we are saying that this the pulses, these modulated signal either have certain values or it do not have certain, or it has zero, it has zero value. That means corresponding to zero binary sequence, it has got no value. So this is also called as on off keying. Or, oh, okay, so if I have to draw the, if I have to draw the modulated signal, how should the modulated signal look like? The modulated signal will be, can anyone help me out? What should be the, how should be the modulated signal? How should be the modulated signal?
It will be same as the carrier signal except for the part where it is zero.
Except for the part where is zero, it should be same, correct? So first I have to draw the guiding lines. So it should be two cycles in here, and then it should be zero for two interval, because the signal itself is zero. So I should write 1 0 0 1 1 0 0 1 and so on. So 0 0, and then it should be again like this. Like this and so on and so forth. So this signal is the modulated signal, is the modulated wave. And if I have to write this, let this be the overall pi ask, pi ask t. So how should I write pi ask t? First of all, I have to write mt in terms of bits. If I have to write mt, which was the message signal, which was coming from, okay, let us say that this was ak. This sequence is ak. Binary input sequence AK. Okay, this is AK, and this was MT was the modulating signal. So if I have to obtain So what we are saying is this AK, okay, yeah, AK can take one of the two values, either 0 or 1. Based on what value it takes, the message signal is generated, which is AK is the binary input sequence. Based on whatever AK we receive, we generate MT. And how are we generating MT? MT, we are making it by pulses, and these are again over K on PT minus KTP. PT minus KTP. Okay. And where what is PT? Where PT is nothing but a pulse, a rectangular pulse. Okay. So if I have to now write the ASK signal, what should I? How should we write it? By ASK. What should be this? What should be this? How should we obtain this? Anyone? How should we obtain this? Anjana, what do you say? Sanjana, are you able to hear us? Sanjana, are you there? I still do not get any response. Ravi, are you there?
Yes, sir.
Yeah, so what should we write? What should we write this phi ASK as? You have any idea? If we have this message signal empty, okay, and we have this carrier wave which is cos omega ct, then how should we write this modulated signal phi ASK t which we have drawn in here? How should we write it mathematically in terms of MT and the carrier wave? Go ahead. Ravi, I'm yet waiting for your answer. Do you have an answer?
No, sir.
No, that's simple. We have already done this thing in the previous lecture.
So
In
if
one
we
of
have
the what?
so if we have an amplitude for this carrier wave,
Hmm.
then we can write it as A plus mt into cos omega ct.
A plus MT. If the amplitude is again fixed and we are not including that, it let be plus 1 and minus 1, and that is again covered in cos omega ct, then we can forget about the amplitude part. We can directly write it MT cos omega ct. Yes or no? Can we write it like
Yes,
this?
sir.
Yeah,
Yes.
correct. So you knew the answer. MT cos omega ct. We can always write it like this, or effectively I can say 2 pi fct cos 2 pi fct. So this is simply the ASK signal, which is this is called as amplitude shift key. This is the ASK signal. Okay,
Sir,
now
so I have a doubt in
yes,
this.
go ahead.
So like it is, yes, sir, so it is a modulation. So it will be mt plus 1 into cos 2 pi fct, right?
So do you remember why have we done this MT plus A? In that case, we said MT plus A plus MT, and then we had this cos 2 pi fct. So what was the reason of doing that? Do you remember? So if I expand this, this was originally MT cos 2 pi fct plus A cos 2 pi fct.
Yes, sir.
Yeah, so why have we done that?
And
To
sir, you
prevent
told
the
me that amplitude is 1.
phase.
Yeah, fine, fine, fine. So do you actually remember originally why have we done this thing?
To prevent phase reversal.
To prevent phase reversal. Yeah, so there were two reasons for that. First of all, this was DSB-SC signal, that is suppressed carrier. So first thing was we wanted to send carrier so that at the receiver, the decoding becomes easier if the carrier is not known. First reason was this, and the second reason was again what she was saying, that if we add amplitude to the message signal, then the recovered signal will be exactly same as what was transmitted, because for the zero crossing, after when the signal goes below zero, that means it when it goes non-negative, yeah, for negative region, in that case there was the reconstruction was not perfect. So because of that we have done in here. But if the message signal, we have already restricted this thing, the message signal is only going to be positive, that is k is equal to 1 or k is equal to 0, empty is like this, because it's not digital signal, it's no longer have a dynamic range. For digital signal we have fixed number of levels on the y-axis, and we know those levels, unlike the analog signal where we had a dynamic range, okay, where the signal can take a set of values from a range. Here there is no range, these are discrete number of values which the signal can take. And now if you are saying that these are positive, then we don't have to worry about that. Have I answered your question, Ravi?
Okay, sir.
Okay, so now moving ahead, so if I now again see the same signal, and if I have to obtain the phase modulated signal, I will just borrow this figure again, and then say if I have to obtain the phase modulated equivalent phase modulated signal, which was, yeah, so if I have to obtain the phase modulated signal, what should happen? How should we phase? So in here I will just write phase at this stage. Yeah, so then if this is the message signal and AK is being shifting like this, so we have to think about it, that how should we altogether do the phase modulated for the same case. How can we do the phase modulated for the same case? Okay, this is not going to shift. Okay, yes. So how are you going to do phase modulators? In the phase modulation, the output should be when there is 1 or 0, the output should be that the phase has been reversed. Yes or no? The phase should be reversed. So that should be the output. That should be the output. So in that way, what we can do, we can in here in the phase in the amplitude modulated signal, that is ASK amplitude shift keying. Okay, we mapped 1 to AK is equal to 1 and 0 to AK equal to 0. But in here, what should we do? We can, if we map in the same message signal, in here, if we map MT, that means AK, if AK takes positive value, if AK is equals to 1, in that case, we can map this thing to, we can map this to a pulse which is positive, and if AK is equal to 0, we can map the pulse which is negative. Okay, if I do that, that means what we are saying is if AK is equals to, so effectively what I'm saying is instead of using this pulse, so instead of using this pulse, what we can do is we can use this. If we use this pulse, and say this is equals to ak is equals to minus 1. If I use this pulse, then what will happen in the same this message signal, in the same ASK modulated signal? Now instead of that, if I say MT is like this, then what can we say? So effectively what I'm saying is, let if the input sequence AK, AK, if AK takes 1, okay, AK, we can map 0 to plus 1, 0 to minus 1. So if AK takes value 0, we map this thing to plus pulse which is minus 1, and if AK takes a value which is 1, we can map this value to a pulse of plus 1. Okay, so this is nothing but PT, and this is nothing but this pulse where this is negative. So let us write it mathematically. So in that case we can write, if AK is like this, so what we are saying, we can map this AK from 0 to minus 1 and 1 to minus 1. Now originally AK took value 0 and 1. Now what we are saying is that AK after this mapping can take minus 1 or 1. So I should not say AK, I should say AK prime, or I can say this one as AK prime, because the sequence and the mapping, these are two different things. So here should be AK prime, AK prime. Yeah, so then AK takes this value minus 1 and plus 1. So in that case, if I have to write the message signal MT would be what? Again the same thing, because AK itself is doing the trick, where AK is not taking values plus 1 and minus 1 instead of 0 and plus 1. KTP, we can write it like this, summation over K, and this is again going to be our modulating signal, which we have drawn, in here like this. This is the modulating signal MT. Now if this is the modulating signal and we have the same carrier, then how should be the modulated signal going to look like? What should be the modulated signal? Anyone? How should be the modulated signal? Anyone can help me out? Yes,
So like in the first
Kamal.
portion, it will be in at
Mhm.
one phase, and after, I mean, in the second block, the phase will reverse.
Correct. So the phase will reverse. And what should be the, so what do you mean by reverse? So what should be the phase
So it
change?
will be like just the mirror image in the like if you put a mirror below this signal, so that portion will come.
So below this signal as in mirror here.
Yes, sir.
Okay, that altogether depends on the axis of the mirror. Yeah, but I got the idea what you were saying. So who was this?
Aditya Sarkar.
Aditya. Yeah, Aditya is saying that for the portion where the signal is plus 1, it should be same as this cos omega ct or cos 2 pi f c t. So then in that case, we can draw this thing like 2 cycles in here. Okay, first let us draw the guiding lines, because the amplitude of the signal should not change. So it should be like this, and where this has turned 0, then in that case it should be starting from, not from plus 1, it should be starting from minus 1, like this, and again there is a 0, so it should be starting from minus 1, like this. From here it should be plus 1, so it should be like this, and again a 1, like this, and then there is a 0, so it should start from negative. Yeah, like this. And a 0, then 0 is being continued, so we have two cycles like this, and then there is a 1, so it should start from +1. Is this plot clear to everyone? So this is what 5 PSK. This is called as phase shift keying. Okay, this is called as phase shift keying. AK can take values 0 or 1, which are being mapped to AK prime, which belongs to, not equal to, this belongs to, AK prime belongs to -1 and 1. Okay, where 1 is being mapped to 1 and 0 is mapped to -1. Yeah. So if we do this, then we can obtain this. Yeah. So we have obtained AK. Did I said it correct? No, I said it the other way around. This was prime and this was AK. Yeah. Okay. So this is what it is. So we have already seen this thing. So this the expression for 5 PSK would be the same as the previous one. The only difference is that AK itself has changed. 5 PSK 5 PSKT is now same, that is MT cos 2 pi FCT. This is phase shifting, but the difference is in MT itself. The difference is in MT itself, because in MT, now these AK belongs to -1 and +1, whereas in the previous ASK, these AK belong to, these AK can take values which is 0 and 1. So that is a difference. That is a difference. So similarly, now there is one more thing which one should be asking. So will there be only two phases like this, or there can be any other modulation technique where we can have multiple phases? First of all, is this equation clear to everyone? Equation B. Is this equation clear to everyone? Shrishti, Toshika, Ravi,
Yes, sir.
Prakash, Kamal.
Sir, I didn't get the question, sir. Modulated signal, sir. How we
Okay,
get?
okay. So let us see. Let
So
us see
the
this
above
thing.
one. Yes, sir.
Yeah. So we have this AK prime, and then from there we obtained AK, and then we have this modulated signal. This is 5 PSK. You are talking about equation number B only. You haven't understood that. Yes.
So modulated signal equation. So the green
Modulated
one.
signal, that is B. Equation B.
So the empty one. Empty is equal to
Modulating
sigma.
signal. Modulating
Yeah.
signal, you mean to say.
Yes, sir. Yes, sir.
Okay. Okay. So now, if you see, okay, let us see. Let us write this thing. Let us write AK prime, and then we will have this MT. Okay, MT. So if AK was 0, sorry, if AK was 0, okay, AK prime was 0, or let it be initially, let us take 1. Then what is AK? If AK prime was 1, what is
So
AK?
a one.
Is 1 only. And what is MT? What is MT?
So
If
one.
if it's a pulse, it's a positive pulse, because this is AKP T minus KTB, which would be what? Which would be a positive pulse like this. Yes or no?
Yes, sir.
So it is going to be a positive pulse like this, and this level is 0. So then what should be the 5 PSK T signal? Equation B. What should be
So the
that?
So the multiple of empty and 1.
Yes, the multiple of MT and 1, that should be, I'm just writing this phi, this thing in between the duration T in the range of 0 to TB. Okay, only in the first block. So this would be what? This should be plus cos 2 pi FCT.
Yes,
Yes or
sir.
no? Because
Yes, sir.
MT is plus 1 in that duration. This duration is TB. So
Yes,
similarly,
sir.
if this is minus, if this is 0, if this is 0, then if AK prime
So,
is 0, what will be AK?
so AK prime will be minus 1, sir.
No, no, no,
A,
AK prime. We have said that the original bit sequence is AK prime.
okay, sir. Okay, sir.
Okay, from there we have obtained MT from saying that, so this is AK prime is 0 and 1. Okay, and we said then AK is equals to plus
Sir,
1 and minus 1.
AK should be 0 and 1.
Yeah, I have just changed the notation. Why? Because I wanted to keep this AK here, AK in this signal. So if you want that, nothing is going to change. We can say
Okay,
this thing as,
okay.
yeah. So won't change anything. So if you want to like do it like this, let us say this. If everyone has confusion in this, so let us say this. AK is this. AK prime is plus 1 minus 1. So then in here it should be AK prime, and above also I should change this to AK and then AK prime. Is this now correct? Consistent with the above also?
Yes, sir.
Yes. So now here I should also change AK and AK prime. Okay. Now what do you say? If this is AK was 0, then what should be AK prime?
Minus 1.
AK prime is going to be minus 1. And then this would be, I should say now in here. Now this should also change. AK prime, you have done that. So then MT is AK prime, this thing, which is plus of this. So because AK prime is 1, so this is P of T minus KTB, which can be drawn it like this. When AK prime is minus 1, this should be minus of P T minus KTB, and that should be a this pulse, where this is 0. Yes or no?
Yes, sir.
So then again, if I have to draw this phi PSK, obtain this expression of phi PSK T again in the interval, this 0 to TB, that means within that interval of 1 bit. So what should be this?
So minus of cos 2 pi FCT.
Minus cos 2 pi FCT. Yeah. So effectively what it has done is, it has done the reversal of the phase itself. If you see, compare these two, if you compare these two, so there is a shift,
Change in phase.
yeah, change in the phase. And that change in the phase, instead of doing actually changing the phase, what we have done is we have done the change in AK prime itself. In AK prime itself, that means in the message signal itself. The mapping is being done in the message signal itself. Otherwise, we can do the same in terms of frequency as well. So instead of saying this, what we could have done, we could have added the two signal if there was no existence of AK prime. In that case, we have to map from AK, whatever AK takes the value in here. Cos, we can write, how can we write it? Another way to write this thing would be, let us see. Let us see. Another way, if we do not had AK prime, then we could have written this thing as phi PSK T is equals to what? MT with the message signal, and then we should have cos 2 pi FCT, and then we should have added this phase plus minus pi based on AK. So we could have said this AK times pi. Can we say it like this?
Yes, sir.
We can say it like this with appropriate. So what will this do? If there is a plus 1, then there is going to be a phase change of pi, and if this is 0, then there is no phase change.
Yes, sir.
Yeah, so like that. So but in here this thing has reversed. Why? Because for 1 there was no phase change, but for 0, so what we can do is we can say this thing as, what should we say? We can say this thing as 1 minus AK, because we want to change 0 to 1 and 1 to 0. You want to change 0 to 1 and 1 to 0. So in that case, if I say 1 minus ak, 1 minus ak, 1 minus ak would do the trick. Yes. So I can say 1 minus ak times pi. Then would it make sense? For when this is 1, when this is 1, so there will be no phase change. And when this is 0, then there will be a phase change of pi.
Yes, sir.
Okay. Yeah. So this this is just the way of writing it. So if we effectively see, if we had 0, okay,
Excuse me, sir.
then yeah, go ahead.
Sir, the previous equation that you erased now,
Hmm.
sir, for that, when empty is less than means empty is minus one,
No,
then
then in that case, empty will not be ak prime. Empty will be ak only. So
okay, then we will
empty,
write it as mod of empty.
yes, yeah, empty would be only ak times p of t minus ktb.
Okay, okay, sir.
I was talking because I was saying that if there is no, if we do not want to do mapping in here, instead we can include this term in the phase itself.
Okay, sir.
Yeah. So what? Oh, this was Akash, is it?
Yes, sir. Yes, sir.
Yeah. So what Akash was pointing out in the previous expression that we have written, in that expression, empty should be used like this, not this. Okay. I hope you have got the idea. Okay. So if this was 0, if this is 0, then we have a phase change of pi. And if this was 1, we have 0 phase change. And this is why this is called as PSK, or phase shift keying. Have I written the complete name? Yes, phase shift keying. This is PSK. Again, this is same as phase modulation, but the only difference is now for phase shift keying, the input signal is a digital signal. It's a digital signal. It's no longer an analog signal. Okay, so this is the only quantification in here. Similarly, if I have to obtain the frequency shift key, now I'm just directly writing the name itself, because we have seen now, if instead of changing the phase or the amplitude of the carrier, if the frequency of the carrier changes, then this is called as frequency shift key. Then this is called as frequency shift key. And again denoted by FSK. In here again, the input signal is not an analog signal. That's a, so I will just again write, paste the same figure and then do the changes there. Yes, so that I don't have to make this AK. Yeah, so if I have to do frequency shift keying, what can we do? Can anyone tell me this? Can anyone tell me this? What should we do? So first of all, so what additions or what substitutions do I need to do? So AK remains like this. Okay, AK remains like this. So we are again going to use the same terminology where AK and AK prime would be the same. So we are going to map AK from 0 and plus 1 to AK prime, which will be again plus 1 and minus 1. Yeah. So yes, can anyone help me out? What should we do? So first of all, if there are two signals, that means the input signal can, or the input binary sequence can take two levels, that is 1 or 0, then for frequency shift keying, denoting each of the level, there has to be a separate frequency. Yes or no? There
Sir,
has to
so
be a
in this
separate
case,
frequency. Go ahead.
so in this case, like whenever it is a high signal in the message one, so at like in that case, the frequency of that modulated signal will be the same as the carrier one. But when the like the value of this message is low, which is
Hmm.
zero in this
Zero.
case, so at
Hmm.
that time the frequency will be much lower than the carrier signal.
Yeah, that altogether depends. So in that case, so what you are saying is making sense, but there is a little catch. There is one thing which you are saying which is a little contradicting, that so there will not be one career, because there are, we are doing what, we are doing frequency shift keying. So based on the number of message signal, we should have those many sub careers. So if this is 1, so there should be FC1, and if this is 0, the message signal is 0, there should be FC2 or FC0 or FC1. So there should be two such carriers. Yes or no?
Yes, sir.
Denoting 1 and denoting 0. So yes. So then in that case, let us say that this is FC1, this is FC1, and there has to be another signal, another carrier signal corresponding to the mapping of, so let us say this AK, if AK is equals to 1, okay, FC1 T, FC1T, FC1T, when we say that AK is equals to 1, AK is equal to 1 is going to modulated by FC1, and when AK is equals to -1, okay, let us say AK prime, okay, AK prime, let me just write it again. What was this SV amplitude? SV, okay, yeah. So like this. So we know that AK is equals to 1. This implies AK prime is also equals to 1. And in this case, we are going to modulate this to FC1. Okay, FC1. We are going to modulate using, we are going to modulate using this carrier FC1. Now, similarly, if I have to draw this, for the FC2 case, okay, we are short of time. Let me just hurry up. Let us say that this has got, we are considering 2 cycles of this. Let us say this has got 3 cycles. Okay, we can assume anything. We can say 3 cycles or 2 cycles. We cannot say just 2 cycles, so we can either say 1 or 3. That means either lower or higher number of cycles. So let us say this has got 3 cycles now. Like this is the carrier. Okay, so this is the carrier, and this is, I'm saying, cos of 2 pi FC 0 t. FC 0 t, this is carrier signal, again the carrier signal. Carrier signal where if AK was 0, then this implies AK prime was -1. AK prime is -1, and we are going to use the carrier signal, this AK cos 2 pi FC naught t with 3 cycles. So again, this should be, yeah, the envelope
Sir,
should be
but you didn't define FC1 and FC0, right?
FC1 and FC0. What do you mean by
Yeah.
that? I haven't defined.
Uh, like, how are you taking 3 cycles in FC0?
Oh, I have just made 2 different carriers. That's it. Which are going to map to one, and which can be, because it's amplitude. So if I go back in amplitude shift keying, there were 2 different, because the message signal, the carrier was changing, the amplitude of the carrier was changing. Okay, the amplitude of the carrier was changing. Yes or no? In amplitude shift keying. But what is happening in phase shift keying? The phase of the carrier is changing. But what should happen in frequency shift keying? In a similar pattern, what should happen in frequency shift keying?
Frequency must increase or decrease.
Frequency must change by the change in the message signal. But how many levels do we have in the message signal?
2.
Only two. So then what should be the two? So how many frequencies should we needing in the frequency shift key?
So like we are having two
250.
carriers.
Yes. So it's not two carriers. So think it like this. What happened in the actual FM modulation? The the if I go back, let us go back and see FM signal. In the FM signal, what happened? In the FM signal, the frequency changed continuously. Depending on the message signal, if the message signal is not constant, then the frequency changed continuously. Yeah, like this. There was not one frequency. There was continuous change in the frequency. That means they were why because the signal was changing continuously. Okay, that's why the increase in the frequency was continuous. But if the signal itself has only two levels, so there should be the change in the frequency should be only at two different frequencies. Yes or no?
Yes, sir. So
Hmm. Go ahead. What is the
so
question?
like in the modulated signal, we
Hmm.
can take two cycles when AK equal to 1 and
This is
three
just an
cycles
this is
when
just an
0.
example. This is just an example. Two cycles or three cycles, just for the ease of so what we can quantify by our eyes.
Yes, sir. Like
Uh-huh.
I'm saying in the same modulated signal, we can represent the two frequencies in a single signal, right? Like in
So
the
I
previous.
can say it like this. So one can say it like this. We can say that the carrier frequency is FC1 plus FC naught by 2. Okay. I can say let this be FC. Okay. I can say this is FC and this is plus 1. I am going to add this portion. I'm going to add this portion or otherwise I'm going to subtract this portion. Will that make your life easier? So what I'm saying is let the carrier be cos 2 pi FCT. Okay. And for the case when AK is equals to plus 1, then I will say that this is FC is this and so FC can take two values. I am saying that FC belongs to two values which is plus minus this. Okay, which is plus minus this. So FC this plus this by 2 FC plus minus this thing. Yeah, FC plus minus this thing. I can say not there is no need of 2. Okay, let me just rewrite it again. FC belongs to FC plus minus. It should be either FC plus. So we want the resultant to be FC
So
naught. Yeah,
So,
go
so
ahead.
it will be FC1 plus minus FC naught plus FC1 by 2.
Yeah. FC 1 plus FC naught. Yeah, can you repeat again?
So it will be
FC.
FC1
Hmm.
plus minus FC naught plus FC1 by 2.
FC1 by 2. No, but this would be only for the case when this is going to work only for not all the cases. This is not going to work for all the cases. This is not going to work for both the cases. So what I want is okay. Let us forget about this. Let's
sir,
simply write
like
this. FC belongs to takes two values, which is FC1 and FC naught. Simply.
yes, sir. Like I was saying,
Hmm.
it FC will take FC1 when AK equal to 1
Hmm.
and it will take FC0 when AK equal to 0.
Yes.
So we can represent it in the same signal instead of two different signals.
Same signal instead of two different signals. These are the
Yeah.
carrier wave. This is not the final modulated wave.
Sir,
Okay, sir.
This is not the modulated wave. This is the carrier wave. So depending on FC1 or FC naught, this is the two carrier waves. If I have to draw the modulated signal is not going to be this. Modulated signal for this portion for plus 1, it should be taking FC1. Okay, for plus 1, it should be taking this portion and for 0 it should be taking these cycles. Yes or no?
Yes, sir. Exactly. Yeah.
Yeah. So the overall signal should be shown in yellow. It should be like this. If I have to draw this, so in this cycle, in the first TV cycle, it should take, if I draw the modulated signal, it should be 2 cycles, because we are this is +1, so it should be modulated by FC1. And yeah, so let me just show you the message signal also. So if this is 0 and 0, then they should be modulated by FC0, and that is nothing but 3 cycles.
So we can write directly FC as FC1 plus FC0 plus minus FC1 minus FC0 by 2.
Yes, yes. So let's not. So what I'm saying is, I wanted to keep it FC1 and FC0. Why? Because I want to just keep life simpler and then write the modulated signal. If I have to now write this by FSK, how should I write this? We can always complicate things in maths, but if this is equivalent, I don't see a point doing that unless and until it serves some purpose. We know that phi ASK. Why I'm doing this thing? Because I want to write this phase frequency shift keying in terms of this ASK signal. I want to write that. So the way in which I'm doing is, again, I will write this thing in the summation part as AK cos, sorry, not AK, then we have to take this pulse P T minus KTB times cos of 2 pi FC1T plus, I'm going to write this thing as 1 minus AK, 1 minus AK. Okay, let me just write it below. Or probably I will rewrite this. Yeah, phi FSK T is summation over K, where this is AK PT minus KTB. Okay, we are almost we are running out of time. I will just write this thing and then let you all think over it and come back to this in the next lecture. 1 minus AK T minus KTB. Okay, what am I doing in here is I'm just checking this AK, and 1 minus AK is going to do the trick. Okay, and then this and cos 2 pi FC naught T. FC naught T. Is this equation making sense to anyone? So AK is again going to be 0 and 1. Based on it being 0 and 1, we are going to turn on one portion over the other portion. Okay, so let's stop at this point. Let's stop at this point. Just think over this expression. Think over this expression, and we can, if you have doubts, we can discuss this thing in the next lecture. Okay, let's stop at this point.
Sir, so in this thing, so can we have multiple levels as well? Like in this, we are having 2 levels. So if I add 3 levels or 4 levels, then in that case, I will be requiring 3 to 4 carriers signals as well.
Yes, this is what I was coming on to. So now what we are doing is, so initially, so this is the most basic form of amplitude shift keying, phase shift keying, and frequency shift keying. Why? Because we are considering this one block as the message signal. Now, the moment I say that there are blocks of 2 and 2, then how many possible combinations do we have?
4.
We will have 4 such combinations. So in that case, if I am doing amplitude shift keying, how many amplitude levels do I require? If I am doing ASK, how many amplitude levels I am going to require? I will be requiring
4, sir.
So in that sense, the carrier has to be the modulated carrier has to be not only for the 2 levels, that is, in here the level is +1 and 0. So for this portion, the carrier peak to peak level is 1. For this portion, for the remaining this portion, what is the carrier peak to peak level? It is 0. So overall, in the complete signal of the modulated signal, what we see that there are only 2 levels, because the message has only 2 possible states. But if we parse them into a block of 2, then it will have 4 possible states. Then in ASK, there should be the final modulated signal should have how many levels? It should have 4 such levels. Okay, so if I have to draw such a signal, okay, probably we can take this thing in the next lecture. And similarly, for phase shift keying, what should be happening? The final signal should have 4 different phases. Am I making sense?
Yes, sir. So it will be as 0, 90, 180, and 270.
Yes, yes. And similarly for carrier shift keying, that is frequency shift keying, there are going to be 4 such carrier frequencies, mapping each of the possible combinations. So let it be that if there is this 0 0, then we can have this 2 cycles, and if this is 0 1, then this can have 3 cycles, 4 cycles, like that. Okay, 1 0, let this have only 1 cycle. Okay, so on and so forth. And then 1 1. So this will be again, oh, this we have already taken, like this. Okay,
Yes, sir.
okay then, yeah. So similarly, I mean, if we can pass this thing into again 3, a block of 3 as well, then in that case, let us say that if we have passed this thing into a block of 3, then in that case, what should happen? If these are blocks of 3, then how many possible combinations are there? Which is 8. In this, there were 2 to the power 2, which
8,
is
sir.
4. Yeah, 8. So similarly, we can expand this thing ASK, FSK, and PSK. Okay, let's stop at this point.